you think factory, what comes to mind? Cars? Electronics? Well, what if I told you that one of the most advanced factories in your city produces something way more essential, clean water? Okay, let's get into it. Now, this might just look like a big concrete basin, but it's actually a critical piece of a highly automated system, a system that turns raw sewage into reusable water, running 24/7. So yeah, it's less like a simple treatment plant and more like a modern water factory. The real magic, though, isn't just in the pipes and the tanks. It's in the incredibly complex control system that acts as the plant's digital brain, managing every single step of the whole process. Look, this isn't just about cleaning water anymore. This is about precision engineering, real-time data analysis, and automation on a truly massive scale. And today, we're going to explore exactly how this factory works, using its very own operations manual as our guide. But before we get to that digital brain, we really need to understand the physical assembly line. So we're going to follow the journey of water as it moves through the 4 critical stages of production right here on the factory floor. Everything follows this super precise path. First up, you've got screening, which is just to remove all the big stuff. Then comes biological nutrient reduction, or BNR, where these amazing little microbes do all the heavy lifting. Next is membrane filtration, MBR, for kind of ultra-fine polishing. And finally, UV disinfection, to make absolutely sure it's safe. Let's break down the challenges at each one of these steps. Okay, so the first and most obvious problem, the raw water coming in is just full of solid waste and debris that can clog up and totally damage the sensitive equipment further down the line. And this right here is the solution, a multi-stage screening process. A series of coarse and fine screens basically act like bouncers at a club, physically blocking anything that doesn't belong before it can cause any trouble. It's simple, but it's absolutely critical. But what about the things you can't see? I'm talking about the dissolved pollutants, the nitrogen, and the phosphorus that can really harm ecosystems. Now, these are much, much trickier to get rid of. This is where the really high-tech biology kicks in. The factory actually cultivates specific microorganisms that literally eat the unwanted nutrients. Then, these advanced membrane bioreactors act like a microscopic sieve, making sure only pure water molecules can pass through. It's pretty incredible. Okay, so we've got the physical assembly line down, but what's actually running the show? Well, now we're going to head into mission control to see this plant's digital brain in action. It's all run by a system called SCADA. And you can just think of that as the ultimate operating system for an industrial process. It supervises, controls, and acquires data from every single sensor, pump, and valve in the entire facility, the whole shebang. And here it is. This is the main overview screen. I know, it might look a little overwhelming at first, but it's actually a really elegant, high-level dashboard. It shows you the real-time health and status of the entire factory, all on a single screen. Now, what's really cool is we can zoom in. Right here in the raw sewage module, operators are tracking the incoming flow rate and pressure. These are the very first data points that tell the system exactly how hard it needs to work. And right here in the BNR and MBR modules, you can see the digital version of that biological process we were just talking about. They're monitoring things like dissolved oxygen levels and the flow rates between tanks. You know, tiny little adjustments here can have huge impacts on how efficiently those hungry microbes are working. So, and this is the crucial point, this is not a fully hands-off system. The SCADA system lets human operators be the conductors of this whole orchestra. From a screen like this, they can adjust what are called set points, like the maximum flow rate, and fine-tune the automated process based on their own experience and knowledge. All this automation is just incredible, but this factory still has to operate in the real world. And that means it requires constant human attention to keep it safe and running nice and smooth. The operations manual lays out a really rigorous schedule. You've got daily tasks, like checking chemical levels and inspecting the screens. But then you also have much bigger jobs every 6 months, like calibrating sensitive instruments and servicing the massive blowers that feed air to the biological tanks. And it is not a risk-free environment, not at all. Operators have to manage everything from biological hazards and chemical exposure to high-voltage electricity and the dangers of working in confined spaces. It really takes a skilled and vigilant team. So what you have is this incredible fusion of biology, engineering, and software all working in perfect harmony.
It's a true representation of the next generation of manufacturing. But what does all this tell us about the future?
Well, despite all the automation, the manual itself says that a core understanding of biological processes is required to operate the plant. The technology is an incredibly powerful tool, for sure, but it's the human expertise that provides the context and makes those critical judgment calls. And this all leads to a fascinating final question. As these systems get even smarter, as they start integrating things like predictive analytics and AI, could we one day see a water factory that runs itself entirely? And what would that mean for one of our most essential resources?